Okay, so question 35, which is the better, nucleophile and methanol? There are 1, 2, 3, 4, 5, 6 total questions for this. I'm going to do 3 of them. So for the first sub-question A, water versus hydroxide, the first thing to look at is whether or not you're comparing apples to apples or oranges to oranges and not apples to oranges. So here, what we're comparing is the nucleophilicity of an oxygen in both cases. So that's the first thing, is we're comparing oxygen to oxygen and not oxygen to a different atom. Okay, so here we have a neutrally charged oxygen and negatively charged oxygen. So in this case, since we have the same atom and the only difference is the charge, in this case nucleophilicity is going to roughly parallel basicity. So of the two, it should be obvious that the hydroxide is the better base. So this is the better base, and so because hydroxide is the better base, it's also going to be the better nucleophile in this case. So better base slash nucleophile. Okay, so if you wanted to prove that to yourself, you could ask yourself about pKa's. So this water right here, the conjugate acid of this guy is H3O plus, and you can compare that to the conjugate acid of this, which is H2O. And so the pKa of that H3O plus is about -2 versus the pKa for the water is about 15. And so between these two, this water is going to be the weaker acid, so it's going to be the stronger base. So this trend will hold the same whenever you compare these two guys. So this water is going to be stronger acid, or weaker acid, stronger base. Okay, so stronger base. So if we have that trend down below, this trend should hold for up here. And in this case, intuitively it does, but we have a little bit more of a numerical answer as to why. Okay, so because the hydroxide is the better base, and because we're comparing apples to apples, oxygen to oxygen, we have the better base in this case being the better nucleophile. Okay, and there's nothing else funky going on. We don't have any steric hindrance or anything like that. Hydrogen, pretty small. You're not going to really have to worry about sterics for this at all. Okay. All right, so the next thing we're comparing is ammonia and water. So in this case, we have two different potential nucleophiles. We either have this nitrogen because the nitrogen has the lone pair on it, or we also have the oxygen as a potential nucleophilic atom. Okay, so these are the two different atoms we're comparing, but we have the same charge. So these are both neutral. So we can actually compare directly. So for this, it's going to have the same kind of comparison. You have two atoms that are on the same row. So you really don't have to worry about the solvent, which we'll have to worry about in a second. But in this case, we can still compare nucleophilicity and basicity. So the nucleophilicity is going to roughly parallel basicity. Okay, so here you can talk about pKa to rigorously talk about basicity. And so the ammonia, you can remember that the ammonia has pKa of about 40. Okay, pKa of about 40, not minus, but about 40. And the water has a pKa of, again, about 15. So between these between these two, we have the ammonia being the weaker acid and thus the stronger base. So the ammonia is going to be stronger base, and also it's going to be the stronger nucleophile. Okay, because in this case we're going along the row, so again nucleophilicity is going to roughly parallel basicity. Okay, this example on the right, this sub-question C, is actually one of the trickier ones, because in this case we're not going left to right or right to left. We're not going across on the periodic table like we were going here. We're actually going down a column. Okay, so this parallel that we were talking about, how nucleophilicity roughly parallels basicity, that rule sometimes holds here, but sometimes it doesn't. So we have to talk about an exception. So these are the really tricky ones. Okay, the important bit here is that we're doing this in methanol. Okay, so we're doing this in a protic solvent. So because we're dealing with a polar protic solvent, the nucleophilicity is not actually going to parallel basicity in this case. And let's see why that is. So let's talk about basicity first off. So basicity of I- versus Br. So we can't actually talk about basicity directly. We can talk about acidity, but in order to talk about acidity, we have to talk about pKa. So going back to that, let's talk about the acidity of Hi versus the acidity of HBr. So the pKa for Hi is about -12 according to our chart, and HBr is about -9. So of the two, Hi is the stronger acid, so the conjugate base is also going to be the weaker base. Okay, so strong acid, weak base. Okay, so again, if we're going to draw a corollary to the conjugate base and then talk about nucleophilicity, we have I-. So I- is going to follow the same trend as Hi. So I- is going to be the stronger acid as well as the weaker base. And then talking about HBr in comparison, this is going to be the weaker acid and the stronger base. And so we don't really want to talk about HBr, so we're just going to talk about Br-. And so Br- is going to keep the same trend. Okay, it's going to keep the weak acid, strong base. So what we're really interested in is this strong and weak base bit. So this is what we're really interested in. I- is the weaker base, Br- is the stronger base. So in this case, if we were going across the row like we were doing up here, we would say that the stronger base is the better nucleophile. But in this case, that's not what's happening. If you're making this comparison up and down the periodic table in a vertical manner, what's going to happen is it's going to invert this trend whenever we deal with protic solvents. So we're going from a species that is relatively non-basic to something that's relatively basic. And once we make this trend, or once we compare this in a protic solvent, what's going to happen is basicity is not going to parallel nucleophilicity. So for protic solvent, it's going to be inverted. And let's go ahead and move these over once more. And in aprotic, this is the scenario where the nucleophilicity will actually parallel basicity. So in this case, if we had an aprotic solvent like DMSO, then the nucleophilicity will actually parallel the basicity. So low to high. So in this case, the nucleophilicity goes right along with the basicity. Okay. And so I guess to answer the question, since we're using a protic solvent, methanol, since we're dealing with protic solvents, the nucleophile is going to be the compound that is the least basic. In this case, that's going to be I-. So for this answer, we're going to be dealing with I- as our better nucleophile.